Imagine stepping onto the surface of Mars, the first human to set foot on another planet. The air is thin, the sky is a pale pink, and beneath your boots lies a layer of fine, red soil. It looks almost inviting, like the deserts of Arizona or Nevada. But don't be fooled. This soil could kill you. Not with a sudden, dramatic explosion, but slowly, insidiously, through a combination of chemistry, radiation, and biology. Mars soil is one of the greatest challenges we face in our quest to colonize the red planet. But why is it so dangerous? And more importantly, how can we fix it? That's what we're exploring today. Scientists have been studying Martian soil for decades, using data from rovers like Curiosity and Perseverance, as well as soil simulants here on Earth. What they've discovered is both fascinating and terrifying. Mars soil isn't just dirt. It's a toxic cocktail of chemicals, radiation, and potentially deadly microbes. Let's break it down. To understand why Mars soil is so dangerous, we need to look at three key factors: its chemical composition, its radiation levels, and the potential for harmful microbes. Each of these poses a unique threat to human life, and each requires a unique solution. First, let's talk about chemistry. Martian soil is loaded with perchlorates, a type of salt that's highly toxic to humans. Perchlorates can disrupt thyroid function, leading to serious health problems like hormone imbalances and metabolic issues. But that's not all. Mars soil also contains heavy metals like lead, arsenic, and mercury, which can accumulate in the body and cause long-term damage to the brain, kidneys, and other organs. Even worse, perchlorates can become even more dangerous when they come into contact with water. On Mars, where water is scarce but not non-existent, this could create a serious risk for astronauts who might accidentally ingest contaminated soil or breathe in dust particles. Next, there's radiation. Unlike Earth, Mars doesn't have a thick atmosphere or magnetic field to protect it from solar and cosmic radiation. This means that the soil on Mars is constantly being bombarded by high-energy particles, which can make it radioactive over time. For humans, prolonged exposure to this radiation could lead to cancer, DNA damage, and even acute radiation sickness. While we can shield ourselves from radiation in habitats and suits, the soil itself remains a problem. If we're going to grow food on Mars or use the soil for construction, we'll need to find a way to neutralize this radiation, or risk poisoning ourselves in the process. Finally, there's the possibility of alien microbes. We don't know for sure if life exists on Mars, but if it does, it could be hiding in the soil. These microbes might be harmless, or they could be deadly. Imagine a bacteria or virus that our immune systems have never encountered before. The results could be catastrophic. Even if Martian microbes aren't harmful to humans, they could still pose a risk by contaminating our equipment or interfering with our attempts to grow crops. This is why sterilization is such a critical part of any Mars mission. So, how do we fix Mars soil? How do we turn this toxic, radioactive, potentially microbe-infested dirt into something we can use? The answer lies in a combination of technology, biology, and good old-fashioned ingenuity. First, we need to deal with the perchlorates. One solution is to wash the soil, using water or other solvents to dissolve and remove the toxic salts. This process is already being tested on Earth, and it could be scaled up for use on Mars. Another option is to use bacteria or fungi that can break down perchlorates into harmless byproducts, a process known as bioremediation. To protect against radiation, we can use a combination of shielding materials, like water, regolith, or even specially designed fabrics. These materials can be used to build habitats, greenhouses, and storage facilities that keep astronauts safe while they work with the soil. Finally, we'll need to develop advanced detection methods to identify any microbes in the soil. If harmful organisms are found, we can use heat, chemicals, or radiation to sterilize the soil before using it. This might sound extreme, but it's a necessary step to ensure our safety on an alien world. Mars soil is one of the greatest challenges we face in our journey to the red planet. But it's not an insurmountable one. With the right technology, the right knowledge, and the right mindset, we can turn this toxic dirt into a foundation for life. The road ahead won't be easy, but as we've shown time and time again, humanity thrives on challenges. Mars is no exception.